Trigonometry. Trigonometry is the study of triangles in relation to their sides and angles. For any right angle triangle, let's say A, B, C, going anti-clockwise, we need to know that the longest side is the hypotenuse, or the sides facing angle 90. So the side facing this box, which is here, is the longest side and is the hypotenuse. Then the next thing we need to note is the angles in the triangle. So let's say we have angle theta here. This angle here measures theta. Maybe it can be 45 degrees, 60 degrees, or 30 degrees, whatever angle. And this other angle measures P. We use these angles as reference angles to know our opposite. So opposite P is this point. So this is opposite P. This is the opposite of angle P, while this is the opposite of angle theta. But then reverse is the case. This is the adjacent for angle P, and this is the adjacent for angle theta. So this simply means, traditionally, if we have a right angle triangle such as this, we have the hypotenuse. Then let's say we have just one angle here, theta. Opposite theta, the side facing theta, which is this end, is opposite. This is opposite for theta. And the other side happens to be the adjacent. So these are the three key parts of a triangle we need to take note of. But in this situation where we had P, what we simply do is that we know that opposite P becomes what? The opposite. And opposite theta is the opposite, while the adjacent for P is the other leg. So there are three basic things we want to note in a triangle. We need to know the hypotenuse, the opposite, and the adjacent. For us to know the hypotenuse is the longest side, or the side facing angle 90. The opposite is the opposite of your reference angle. So if theta is your reference angle, then the opposite is the side facing theta. Then if you have another angle, whether beta, gamma, or P, like we have here, the side opposite P happens to be your opposite. So we need to identify the reference angle first, then we can now know our opposite or our adjacent. While for the hypotenuse, we do not need to identify our reference angle to be able to find our hypotenuse. So take note of this. We need to note our reference angle in order to find the opposite and adjacent, which means it is very, very essential you know the reference angle before you talk about the opposite and the adjacent. While for the hypotenuse is the side facing angle 90, or the longest side in the triangle. Having said that, let's continue. Three basic trigonometric ratios. One, we have the sine, we have cosine, which is cos, and then we have tangent, which is tan. We apply SOHCAHTOA to find the three basic trigonometric ratios. We said we have sine, cos, and tan. And then we use SOHCAHTOA to define these three basic trigonometric ratios. So this is the first one, the second, and the third. For the first one, which is sine of any angle gives us what? Opposite over hypotenuse. So I'm just taking the short form. Now this is opposite over hypotenuse, and then the cos of anyone is what? Adjacent over hypotenuse. Cos is adjacent over hypotenuse, and tan is opposite over adjacent. Opposite over adjacent. So let's go ahead and make more sense out of this. Assuming we have a triangle, a right angle triangle, let's say A, B, and C. Then these triangles will label various parts. So let's say for this part, the point facing A is CA, this other point facing B is TB, and this other point facing C is TC. So from these very points, we want to identify upness, the various parts in this triangle. We need to know the hypotenuse, the adjacent, and the opposite. So the hypotenuse is the point measured C, which is here. Now up next, we want to find the adjacent and the opposite. So for us to find the adjacent and opposite, we have to introduce a reference angle, or we have to work with the reference angle that is being given. But right here, we don't have any reference angle. So let's say the reference angle here is theta. What's next? It simply means that the opposite is this, A, and the adjacent is B, because you are working with this reference angle. So what's next? Let's apply the trigonometric ratios here, the basic trigonometric ratios here. So first, applying, so we can say applying so ka tua sine theta is equal to opposite over hypotenuse, and opposite is what? Is A, and hypotenuse is C. That gives us A over C. So the next is cos theta. Cos theta is adjacent over hypotenuse. And our adjacent here is B, and the hypotenuse is C. B, and then we'll have C. Then up next we'll have tan theta, which is equal to opposite over adjacent. And opposite here is what? A, and adjacent here is B. Reciprocals of three basic trigonometric ratios. So first we'll have cosecant, which is 1 over sine. Then we'll have secant, which is 1 over cosine. And then we'll have the cotangent, which is 1 over tan. Still working with what we had before, let's say angle A, B, C. So let's say this is A, this is B, and this is C. So let's solve for the, and then we'll have angle theta. Now we're solving for the reciprocals of the three basic trigonometric ratio. And we said we have what? We have cosec, which is 1 over sine. And then we'll have sec, which is 1 over cos. And then we'll have cot, cotangent, which is what? 1 over tan. So let's go ahead and let's check this again. So remember, so looking at this, we'll know that we have what? Cosec 1 over sine, secant 1 over cosine, and then cotangent, which is what? 1 over tan. Cosec theta here, which is 1 over sine, simply means that we have 1 divided by sine. And what is sine? Sine is what? Opposite over hypotenuse. So what is the opposite? So remember, let me put it here. Sine is opposite over hypotenuse. And what's the opposite? Our opposite is A. Using our reference angle, which is theta, the opposite is what? A. So A over, and what is our hypotenuse? C. Then we can now have 1 multiplied by C, taking the reciprocal now, over A, since we have division. And when we change this division to multiplication, then the denominator goes up, and then the numerator comes down. So having said that, we're going to be left with what? C over A. Now, remember that sine theta using this is what? Opposite, which is A over C. So the reciprocal simply means that what? We are going to have C over A. And that is what it simply means here. So instead of you to go through this process of or 1 divided by the trigonometric ratio, you just flip whatever you have. Okay, let's solve for sec. Sec theta is equal to what? 1 over cos. Okay. Now, having said that, for us to be able to do this, what is cos? So let's do cos here. Cos theta here is giving us what? Now using, don't forget to use this at all points. So ka tua, cos theta is what? Adjacent to hypotenuse. So what is our adjacent? From our reference angle, adjacent is B and hypotenuse is C. So we'll have B over C. Now the reciprocal of this is simply what? C over B, and that should be equivalent to what? Sec theta. So let's do that and find out. So we'll have 1 divided by what is cos theta? Cos theta here is adjacent over hypotenuse, which is what? B over C. So B over C, and that becomes 1 multiplied by C over B, right? Which is same thing as C over B. See that this is exactly the same thing with this. So once you are able to take the reciprocal, you don't need to go through the whole solving process again. Okay, lastly we'll have cot. Okay, C-O-T, cot theta, which is what? 1 over tan. 1 over tan, right? So 1 over tan. So we can now have cot theta is equal to 1 divided by what is tan theta? Tan theta is opposite over adjacent, and our opposite is A over B. So taking the reciprocal, I'll have 1 multiplied by B over A, and then we are going to be left with what? B over A. And that is just it. No complex, nothing confusing. It's just for you to understand. Now I want you to take note of this. Be mindful of the basic trigonometric ratios and their reciprocal. Sometimes things can become complex or it can become confused and then you misplace them. So be very careful while working with the trigonometric ratios and their reciprocals. Okay, now we've moved to special triangles. Okay, so special triangles, trigonometric ratios. Okay, we'll have the angles of 45 degrees and then we'll have the angles of 30 and 60 degrees, which are going to see in the later part of this lesson. So for now, we'll have the angles of 45 degrees. So for angles of 45 degrees, we use the mathematical assumption that follows: a right angle triangle whose theta, which is this, is 45 degrees with opposite and adjacent sides of 1 unit. Now you see that we are given a reference angle. So because we are given a reference angle, we don't need to start struggling to figure that out. So we know that here, this is the hypotenuse, this is the opposite, because our reference angle is here, and then this is the adjacent. So we didn't need to start racking our head because we're already given the reference angle. If you've done this, you've done the first step. We need to follow this assumption that says with opposite and adjacent side of 1 unit. So this is 1 unit. So it means that opposite is 1, measures 1, and then adjacent as well measures what? 1. So what we don't know is the measure of the hypotenuse. But then applying Pythagoras theorem, we can apply Pythagoras theorem to figure out that. So let's say let's solve here. Applying Pythagoras theorem, we know that the hypotenuse squared is equal to opposite squared plus adjacent squared. This simply means that the square of the hypotenuse is equal to the square of the opposite and adjacent. That is the square sum of the opposite and adjacent. Let me take it again. The square of the hypotenuse is equal to the square sum of the opposite and adjacent. So having said that, can we just give this let's give our hypotenuse a value. So let's say our hypotenuse is y, for instance. So we now have y squared is equal to from the assumption that opposite is 1 squared plus adjacent is also 1 squared. Here we now have y squared is equal to 1 squared is 1 plus 1 squared is also 1. So y squared becomes 1 plus 1 is 2. Now at this very point, we have to take the square root of both sides for us to be able to make y stand alone. So we take square root of both sides. So y squared is equal to y squared all squared, and then taking the square root of 2, so we have a surd here. Now having said that, we are going to be left with what? Y is equal to what? Just surd 2. So therefore we have surd 2 here. Okay, so let's apply SOHCAHTOA to this. SOHCAHTOA, which means we are bringing in the basic trigonometric ratios into this. So for the first one, let's say sine 45 degrees, which is what? Sine is opposite over hypotenuse. So opposite over hypotenuse. So from here, what is our opposite? Our opposite is 1. So sine 45 degrees equal to opposite is 1, and then our hypotenuse is sod 2. But we are not done with sod 2. We have to, because a sod cannot be the denominator in a fraction. We always have to rationalize. Now this is why I need to check out for the previous lessons on sods, check out for the lessons on rules of sod and rationalization of sod. So here we can have 1 over sod 2 multiplied by sod 2 over sod 2, such that you are left with 1 multiplied by sod 2 gives us sod 2 over 2, and that is our sine. Now this might be very complex at first or looking confusing, but it's actually very, very simple. Okay, let's do one more. Let's solve for cos. So let's say cos 45 degrees is equal to what? Is adjacent over hypotenuse. So ADJ over HYP. So let's continue from here. So cos 45 degrees is equal to, what is our adjacent? Adjacent here is 1. Hypotenuse is sod 2. Okay, exactly the same thing is sod 2. So we're going to still be left with, so since it's the same, we're going to still have sod 2 over 2. So let's solve for the next one, which is tan 45 degrees is equal to what? Opposite over adjacent. What is opposite? Opposite is 1 and adjacent is 1. 1 over 1 is same thing as what? 1. So you see that having known this, we've been able to identify the trigonometric ratios for this special angle 45 degrees, and it's very simple. Now if you get confused at any point of this lesson, I want you to pause the lesson, then go through the lesson again. Okay, for angles of 30 and 60 degrees, so we use a mathematical assumption of an equilateral triangle of size 2 units. Okay, don't mind my capital letter on this. This should just be WE. Okay, so having said that, if we go further to work on this triangle, let's say let's transform, we can have something of this nature. I want you to do this together with me. Okay, don't mind my drawing. So if we split this triangle, we can have this as various angle 90 degrees. Here remains 60 degrees, but then here is going to be 30 now, 30 degrees, and then 30 degrees, while here remains 60 degrees. So since this place is 2, we can remain 2, but here becomes 1, 1, and then we still have 2 here. So moving further, we can finally resolve to something of this nature. Can resolve to a right angle triangle of the form where here is 60 degrees and here is 30 degrees. So I'm taking one part. If your diagram is of this form, let's say this form, there is nothing wrong with it. It's still absolutely correct. So this is 60 degrees and here is 30 degrees, such that here is 2 units, here we have 1 unit, and here we don't know what it is, so I can call it y or any variable. Okay, so which is same thing here, y or any variable. Here is 2 units and here is 1 unit. Okay, having said that, let's apply Pythagoras theorem for us to be able to solve for the value of y. So applying Pythagoras theorem, we know that from here, this is our hypotenuse. Whichever one, whether we use this or this, exactly the same thing. So we know that the longest side is our what? Hypotenuse, and is equal to 2. Now from this reference angle now, what is our opposite? So our opposite is y, and then our adjacent is this, if we are using 60 as our reference angle, remember. But if we are using 30, this becomes our opposite and this becomes our adjacent. So let's use 60. Any of them will give you the same value. So our hypotenuse is 2, so the square of the hypotenuse is equal to the square sum of the other side. So let's say y squared plus 1 squared. So 2 squared is 4. 2 squared simply means 3 raised to the power 2, that's 4. And then here it remains y squared plus 1 squared is 1. So collecting items here, we can have that 4, 1 moving here becomes minus 1, and then y squared, which is 3, is equal to what? Y squared. Okay, let's go from this point. So taking the square root of both sides, so we have a sod now. So sod 3 is equal to y. It simply means that y is equal to sod 3. Even if you had considered this as if you had taken this point as your opposite, which is 1, and then taking here as your adjacent, which is y, you would have still gotten the same value while solving this. So if you're not yet cleared, you want to try it yourself so that you can see. So let's apply SOHCAHTOA to what we just did. Okay, let me just put up a quick sketch for what we just did now. So this is 60 degrees and this is 30 degrees. Know that this is 2 units, this is 1, and this is sod 3, just like we solved for right now. Okay, so the first is sine. So let's say sine 60 degrees is equal to what? Is equal to opposite over hypotenuse. And what is the opposite? The opposite is what? This. So for sine 60, this is the opposite, the point facing its opposite, which is what? Sod 3 over hypotenuse is what? 2. So I'm just going straight, opposite and then hypotenuse. Okay, let's solve for cos 60. Cos 60 degrees is what? Adjacent. So this is the adjacent for this, adjacent, and then this is the opposite. Okay, let's do this way. For 60 degrees, this is the hypotenuse, this is the opposite, and this is the adjacent. So the adjacent is what? 1, and the hypotenuse is 2. So let's solve for tan 60 degrees. We'll have opposite over adjacent. So the opposite is what? Sod 3, right? And the adjacent is what? 1. And that is it. I don't know if there's any confusion. Okay, let's do same thing for 30 degrees. So let's say here is 60 degrees, here is 30 degrees, this is 2, sod 3, and 1. So this is for 30 degrees. This is the hypotenuse, this is the opposite, and this is the adjacent. So this is where you have to be very careful, because we deal with reference angle in order for us to identify our opposite and adjacent. Hypotenuse are pretty easy to identify. So let's say sine 30 degrees is equal to what? So okay, let's do that here. SOHCAHTOA, opposite over hypotenuse. What is the opposite? The opposite is what? 1 over the hypotenuse is 2. Then cos 30 degrees is adjacent over hypotenuse. So what is the adjacent? Adjacent is what? Sod 3 over hypotenuse is what? 2. And then tan 30 degrees is opposite of adjacent. What is opposite? Opposite is 1. And then adjacent is what? Adjacent is sod 3. But we can't just stop there, because we have a sod as the denominator. We must rationalize. So multiplying by sod 3 over sod 3, we are going to be left with 1 multiplied by sod 3 is sod 3, and sod 3 multiplied by sod 3 is 3. Now, if you don't understand how we got this final value, it's very necessary you check out for the lesson on sods and rationalization of sod. Very, very necessary. It's very, very important. Okay, let's go ahead and solve some questions. We'll have some quick exercise. Now, find the value of the unknown side. Okay, so we know that the reference angle is 45. Therefore, this is our opposite, right? And this is our hypotenuse, which is given as K. And here is our adjacent, which is given as what? 8. If you can do this, then you are almost done with solving this question. So what's next? Okay, let's identify this. Let's write down this. SOHCAHTOA, so we can know the right trigonometric ratio to use. So this is sine, cos, and tan. Now we have values for adjacent and then hypotenuse, and that is what? Cos. It aligns with cos. So cos is equal to what? Adjacent over hypotenuse, and we are given variables based on adjacent and then hypotenuse. So therefore we have to work with cos. If we use sine, look at the challenge with sine. Sine says opposite. There is nothing for opposite, so we can't work with sine in as much as we have hypotenuse. And if we use tan, which is opposite of adjacent, we do not have opposite as well, and then it doesn't incorporate our variable, which is k. In fact, tan is a no because tan does not even incorporate k, which is the missing value. So let's say cos 45 degrees is equal to what? Adjacent over hypotenuse. And what is the adjacent? From here we know this is 8. Adjacent over what is hypotenuse? Hypotenuse is what? K. Now there's a little bit of problem here because we might not be able to go further without identifying something. What is cos 45? Let's solve for that. So from the special triangles, you know that when you have a special triangle like this, and then this is 45 degrees, because both of them measures the same thing. The opposite side are 1 unit. We have already solved and said that using Pythagoras theorem, this is sort 2. We can check out for just the previous aspect of this same lesson, just a little bit in the previous slide. You see where we solve for that. This is sort 2. Okay, what is cos 45? So cos 45 here is equal to what? Adjacent, right? Over, okay, let's write it down. Adjacent over hypotenuse. And what is adjacent? Adjacent is 1 from what you can see, and our hypotenuse is sort 2. But we can't have sort 2 there, so 1 over sort 2 multiplied by sort 2 over sort 2, we are going to be left with sort 2 over 2. So therefore, we have to change this now to what? To sort 2. So we have sort 2 over 2 is equal to 8 over k. At this point, you can cross multiply. Okay, don't mind me trying to write fast. So we have sort 2 multiplied by k is equal to 2 multiplied by 8. So this multiply this multiply this. So this becomes k sort 2 or 2 sort k. And sort 2k, anyone. 2 times 8 is 16. So we have to divide both sides by sort 2. Let's continue from this very point. So k sort 2 over sort 2, because that's the coefficient of our variable k, and then 16 over sort 2. The sort 2's can cancel out. Then k is equal to 16 over sort 2. Now, because we have a sort here as denominator, we always need to rationalize. So sort 2 over sort 2. Like I said, if this is actually complex for you, check out for the lesson on sorts. It's very, very fundamental to you understanding this. Okay, so this is 16 sort 2 over 2. So 2 here is 1, and 2 into 16 is 8. So that we can be left with k is equal to 8 sort 2. And we are done. It looks a little bit complex at first, but when you go through this lesson over and over again, like after now, at the first time, you might be confused, but go through the lesson again. Going through it again helps you to internalize the whole process and all that. Okay, so we have another question, and we're meant to solve for the variable v. So let's know that this is our reference angle, right? So this is opposite. We have opposite, and then we'll have hypotenuse. When we use SOHCAHTOA, which of these trigonometric ratio employs opposite and hypotenuse? Sine. So therefore, we don't need to rack our brain. We just need to go ahead and use sine. So sine 60 degrees is equal to what? Opposite over hypotenuse. Sine 60 degrees is equal to, what is our opposite? 3, and our hypotenuse is v. But before we do that, what is sine 60 degrees? So we'll have this special triangle of 60 and 30 degrees. Here we'll have 2 here, 1, and then this is sort 3. So let's solve for sine 60 degrees using this special triangle. Sine is what? Opposite over hypotenuse. What is our opposite? Opposite is sort 3 over 2, right? So let's put that in here. So let's have sort 3 over 2 is equal to 3 over v. Continue from this point, you can now cross multiply. So we'll have that sort 3 multiplied by v is equal to 2 multiplied by 3. So this is what? V sort 3 is equal to 6. Let's divide both sides by sort 3, because that's the coefficient of the variable v. So v sort 3 over sort 3 is equal to 6 over sort 3. So that we'll have v is equal to, the sort 3 is cancelled out, 6 over sort 3, right? But because we can't have a sort as denominator, we'll have to rationalize. So multiply by sort 3 over sort 3. So that v is equal to 6 sort 3 over 3. 3 here is 1, and 3 here is 2. So that v becomes 2 sort 3. And that is it. So beautiful. So beautiful. I believe at this point you are getting the whole effigy. So let's identify the special triangle for this. So let's say we have 30 degrees and this is 60 degrees. So we know that here is 2, here is 1, and this is sort 3. And our aim is to identify what is tan 60 degrees And then what is tan 30? So tan 60 degrees, tan is opposite over adjacent. So tan 60 is opposite sod 3 over adjacent is 1, which is same thing as just sod 3. Let's check tan 30 degrees. Tan 30 is opposite of 30. So let's look at this. Opposite here is 1, and then the adjacent is sod 3. So we'll have to rationalize, and that gives us sod 3 over 3. Okay, so now we have what are the figures we need. Let's go ahead and start solving. 1 plus, what is tan 60? Tan 60 is sod 3. We just did that here. And then multiply by tan 30. So 3 over 3 divided by tan 60 is sod 3 plus tan 30 is sod 3 over 3. From this very point, 1 plus sod 3 multiplied by sod 3 gives us 3 and over 3 divided by, solving this fraction, we can have, okay, let me use this simple method, over 1. So this becomes, using this 3 to multiply both sides. This is just simplification of fraction, addition of fractions. Okay, let's use 3 to multiply both sides here and 1 to multiply both sides here. So 3 over 3 multiplies sod 3 over 1, and then plus sod 3 over 3 multiplied by 1 over 1. Okay, so this becomes 1 plus 1. 3 here is 1, 3 here is 1. 1 over 1 is just same thing as 1 plus 1. And then this becomes 3 sod 3 over 3 plus sod 3 over 3. I know it's looking a little bit complex now, but it's the same process. 1 plus 1 here is 2 divided by, now we can just simply add these fractions because we have common denominators here. 3 sod 3 plus sod 3, that is 1. So this becomes 4 sod 3 over 3. Okay, let's continue from this very point. So we'll have 2 multiplied by, so we'll take 3 over 4 sod 3. From this very point, let's multiply 2 times 3 is 6. So we'll have 6 over 4 sod 3. But the challenge here, we can't have sod as the denominator. So let's rationalize. So we can say, okay, let's cancel that. 2 here is 2 and 2 here is 3. So we'll have 3 over 2 sod 3. So rationalizing, 3 over 2 sod 3 multiplied by sod 3 over sod 3, so that we can have 3 sod 3 all over 2 multiplied by, so 3 times sod 3 is just 3, is equal to 3 sod 3 over 6. 3 here is 1 and 3 here is 2. So we are left with what? Sod 3 over 2. I think this one is a little bit more complex, and what you simply do is pause the video and take notes. Maybe go through it a couple of times, then you definitely understand. Okay, another thing I want to talk about is this very point where we had to simplify this fraction. If you missed it at this very point, I think you want to check out for the lesson on simplification of fractions. So if you don't know how to simplify fractions, you might find these very points a little bit challenging. So that was just what we did. And then up next, from this very point, we had to rationalize as well, because we can't have a sod as the denominator of a fraction. So that's just the two complex part that you might consider overboard. But having said that, everything is cool. Okay, and the last question. So we are meant to solve for the value of y, but then we'll have two right angle triangles joined together in some kind of difficult ways. Okay, so we need to find this part. Let's call this part maybe x. We need to find this part. So here, which is 45 degrees, we have y, and we don't have another information that can help us. But from here, we have one information here and that information here. So let's go ahead. So this becomes our what? Hypotenuse. So I'm going to solve for this point, and then we'll come to this point now. And this becomes our opposite, which is what? X. Applying SOHCAHTOA. What can relate opposite and hypotenuse? Say opposite and hypotenuse, that is sine. So sine 60 degrees is equal to what? Opposite is x over hypotenuse is 8. So from special triangles, we know that this is 60 degrees and this is 30 degrees, which means you need to be very familiar with special triangles. This is 2, 1, and then sod 3. So what is sine 60 from special triangles? Sine is opposite, right? Sod 3 over 2 hypotenuse. So sod 3 over 2 is equal to x over 8, such that we'll have 2x is equal to 8 sod 3. Okay, let's divide both sides by 2. 8 sod 3. So 2's cancel out and x is equal to what? 4 sod 3. So that's the value of x, 4 sod 3. So for angle 45 degrees, now we have, this is hypotenuse here, and then we have the adjacent, right? Adjacent. For 45 degrees, we need to understand which, since SOHCAHTOA, which of these applies for adjacent and hypotenuse, which is cos, right? So cos 45 degrees is adjacent, which is 4 sod 3, like we've solved, over hypotenuse, which is what? Y. What is cos 45 degrees? Now, let's go back to special triangles. So this is 45 degrees, 45 degrees. 1, 1, and then sod 2. Cos 45 degrees is adjacent of hypotenuse, which is cos 45. Adjacent is what? 1 over sod 2, but we can't stop there. So 1 over sod 2 multiplied by sod 2 over sod 2. That gives us what? Sod 2 over 2. So we have sod 2 over 2 is equal to 4 sod 3 over y. So cross multiplying, we have y sod 2 is equal to 2 multiplied by 4 sod 3. So y sod 2 is equal to 8 sod 3. So divide both sides by sod 2, we have y sod 2 over sod 2 is equal to 8 sod 3 over sod 2. Cancel this out. Let's continue from this point. So 8. So okay, let's say 8 sod 3 over sod 2 multiplied by sod 2 over sod 2, and they are all equal to y. But it's fine, let me bring our y here now. So 8 sod 3 multiplied by sod 2 gives us sod 6 all over. Sod 2 multiplied by sod 2 gives us just 2. So that you are left with 2 here is 1 and 2 here is 4. Left with what? 4 sod 6, and we are done. This lesson was quite a long one and somewhat stressful, so I plead with you to go through this lesson again and again for you to internalize the whole process. Thank you so much for watching. Thank you so much for staying to the end. Please ensure you like, subscribe, and share to your friends who need this. Having said that, join us next time. Thank you for being here today. It was nice having you.